What's up guys, Shawnthebro here, and we're back for another episode of the fighting game tutorial series. In this episode we are going to be continuing to go over improving our character class for our game. So for the last few episodes we've been working on cleaning up our game. After all these 300 episodes that we've done, technically we've done more than that even, because we've had a lot of generic episodes or bonus episodes that I did not include in that count. But after these 300 official episodes in the fighter, we are here and we are almost ready for some of the really important parts of our series, which is online rollback, finishing up regular online multiplayer just so that we can use it, AI, and story mode. Since we're here, I took some time to reflect in the series and clean up a lot of our old classes that had done things less than optimally. A, I learned some new things and improved them over the course of this series. B, we just did some things to get it working in the moment with what we had. Then we updated a certain mechanic or a certain feature and it really fit into place, so we updated all of that logic. And recently we've been cleaning up our character blueprint and converting a lot of the blueprint functions to code to make them more efficient and also more extensible. That way we could actually access them from everywhere, not just blueprints, which gives us the ability to do more things, and we're already seeing some of the benefits from that. So for today's episode, we're going to continue going over hurt boxes. So if you remember in the previous episode, we were going over hurt boxes and we were making sure that we could change their size, reset them, do all these different things to them in the code, and we couldn't before, but now we can. The next thing we want to do with them is be able to assign them, grab their default values, all within the code, because right now we set up our hurt boxes on the character blueprint, which I think is the correct spot to do that. This makes sense because each character will have their own hurt boxes, and so we can visualize them and define them how we want for each character. However, every character is going to then take those hurt boxes that they have assigned and add them to an array that we can access while we're playing the game. That way we can determine things like collision on those hurt boxes, resizing the hurt boxes like we were doing in the previous episode, and which hurt boxes are active. And these are things that we should also be able to do from the code, and currently that is a blueprint function that sets that up, so we're going to convert it to code. As a bonus, I will convert the 3D hurt boxes to code for that function as well, because we do have this complex hurt box behavior. So if we enable 3D mode, we get our 3D hurt boxes, and these hurt boxes have very similar behavior. They're slightly different. We still need to track them properly, and we do so in their own array. So I can also port the complex hurt box behavior from blueprint to code, and we'll eliminate both of those blueprint functions and make them easier to use from anywhere and better on performance. Now, before we hop into the episode, if you want to get caught up and see everything we've done to date, from our 2D and 3D mode, our projectiles, our practice mode, our input stack, and a whole lot more, I'll link you to the entire fighting game tutorial series playlist right here in the top right corner, so you can check all of that out, so you can get familiar with how we've done all of that. Alternatively, if you only care about keeping a clean character blueprint and converting functions from blueprint to code, that's perfectly fine. You don't have to follow along with the whole series to do all that. But I do recommend you check out the other episodes of the cleaning up the character blueprint, because there's a lot of good information in there, and it will show you why I want to make these changes in today's episode. So I think they are important. I'll link you to the first one right here in the top right corner. With all that out of the way, we can go ahead and get started. So this is a code and blueprint tutorial series, and specifically we're going to be working in both the blueprints and code today, because we are going to be converting logic from blueprint to code. First things first, let's go to our character blueprint. It's in content, blueprints, character BPs, base character BP. Then when we're in our character blueprint, you'll see it's significantly smaller than it once was. We have a few functions in here. This list is also much smaller than it once was, and we want to go to our set simple hurtbox details and set complex hurtbox details. So these functions, as I mentioned in the intro, basically find all of our hurt boxes and assign the default values to a structure in an array. This allows us to keep track of them so that we can easily modify a given hurt box at a given index. And then another thing we do is determine if they can be visible or not. This is determined based on the game instance and the game mode type specifically within that game instance. Our game mode type, not to be confused with the actual game mode itself, but just the type of match that we're in, like versus, practice, story, arcade, or online. These determine certain properties about our game, and in this case, only practice mode has the hurt boxes visible. We also have set complex hurt box details, which does a very similar thing here. They do get added to their own array, and we do have separate things that we check for in our string. And this is because really your game likely won't have 2D and 3D hurt boxes. They'll have one or the other, but they could. Some games do have the ability to do this. A good example would be Pokken Tournament. So I've made them completely separate so you can use them together, but you don't have to. And then also these are determined to be visible or not based on the game instance's game mode type enum value. So these are the functions we're going to be converting today, and we can go ahead and do that. We can go into the code, and specifically we want to go to our fighter template character.h, which is our base character, or the parent to our base character BP. Then we want to scroll down to where we want to make these functions. You can make them pretty much wherever, but I am going to put them next to my other hurtbox functions because I think that makes sense. And on top of it making sense, I also want to make them ufunction blueprint callable like these ones so that we can call them from the blueprint. So I'll make two functions here. The first one I'm going to say for the comment, assign the proper values to the hurtbox, such as visibility based on game mode type, and add it to an array for tracking. And something like that will be good. Then we can go ufunction blueprint callable so that we can call it from the blueprint, but we can fill it out in the code, and then we want to make it void. And we don't have to give it the same name. So in here it was called set simple hurtbox details. And if you want, you could call it that, or you could just rename it to be something like set up hurtbox or set up simple hurtbox. I like this idea of setting it up, meaning we're doing everything that's required of it once it's created and ready for use. And then we can go ahead and basically copy this. I do want to make a change here. Assign proper values to a simple hurtbox. I'll say simple 2D hurtbox. And so if I copy this, I can paste it here. This one will be assign proper values to a complex 3D hurtbox. This part can stay, such as visibility based on game mode type, and add it to an array for tracking. Ufunction blueprint callable, yes. We'll call it void setup complex hurtbox. Now we have both of our functions ready in the header file. Let's go to the fighter template character.cpp and scroll down to our hurtbox functions. Here, so we can go above this and make these functions. So void a fighter template character, set up simple hurtbox. And the blueprint function doesn't have any parameters or a return type, so we don't need to have one here either. So we're good, and neither does set complex hurtbox details, no return type, and no parameters. So we can come down here, void a fighter template character, set up complex hurtbox. And now we can start transferring over the logic. So the first thing that we do is grab the mesh and get all children components of it. We do this because depending on what components we may have plenty of other things that aren't related to hurtboxes. In the base character BP, it's only the hurtboxes, and even in some of the other characters, like our mutant, it is the complex and simple hurtboxes and nothing else. But if you wanted to attach something else, then you don't want to try and count these as hurtboxes and add them to the array. That would be funny. So instead, we're going to get all the components, and specifically we're going to loop through them and only grab the static mesh components of each. Now for the mesh, we happen to have a character mesh. We can get mesh, and this will get the character mesh. So simple enough. And then we can arrow get children components. Now you could check if this mesh was valid if you want to be really safe, but it definitely should be here. So for me, that is fine. And then when we're getting children components, this is going to return an array of all of the children of the component, which is the mesh. So we'll put this into a for loop for i equals 0. I is less than get mesh get children components dot num and plus I. This is how we would normally do for loops, and we have done this mainly in the series, but you can also do something else called a range-based for loop. That means we're not going to do indices like this. Instead, what we can do is type scene component pointer child component space colon, and then we take out the rest of this and just have the container that we want to iterate through. So then it would be for use scene component pointer child component colon get mesh get children components. And what this is doing is literally looping through each of these and returning the child component at the specific index. So you don't have to go into it with index I. This is just something that's available to you. It fits more closely with what we're going to be doing here. So I wanted to show that to you. You can definitely still use index I and just access the scene component at index I, and it will work perfectly fine. This is available to you if you choose to do it. So at this point, then you can cast it to a certain type. So if you static mesh component pointer, static mesh child component equals child component. But we need to cast this to the specific type. So cast to use static mesh component. And we're passing in child component to the cast. So if that child component can be cast to a static mesh component, then you know we're good. And we need to fill out this parameter for get children components, because I remembered when I come over here, yes, the target is here, but we need to set false for include all descendants. This will do a recursive search. So say I had a component here that was a child and then it had children. If this is false, it will only include the top level. If this is true, it will include this and all of its children. So it's up to you how you want to set that up. You could want true or false. I'm going to put it to false. And then we need to give it an array to set these values to. So we can make a T array of scene components. So T array, use scene component pointer, mesh components. Then you can pass the mesh components in here. But with the way this works, this isn't directly returning the container. The container is being put into here. So what we need to do is take this section out of here. So we make our mesh components array, assign the values in it just by running this line right here. And then we're going to iterate through our mesh components container. Retrieve all children components of the character's mesh. Okay, so that's what we're doing there, and then this for loop is iterating through each one. For each one, if it is a static mesh component, then we are good to use that to then check the tags. So at this point, we can simply do this check that we were doing here. So each of these static meshes is named with the prefix HB underscore. And I did this on purpose to say hurtbox so that I know if the component is a hurtbox or not. We can check this the same way we're doing it in the blueprint here. So if static mesh child component get name dot contains, and we want to put quotes HB underscore. So this will work. You can also do dot starts with. That will work because we are starting all of our strings with this. So starts with basically just checks the first characters. If it doesn't match with the first set of characters, then it will fail out, but all of our instances will match for that. So now we have this check in here. Then at this point, we know that we have found one of our hurt boxes. So we want to add it to the simple hurt box array. So simple hurtbox array dot add, and we want to add our static mesh child component here. Then after that, we were using the data from that object, because we know it's a hurtbox, to add it to the hurtbox defaults array. This is something we converted to code in the previous episode. That way the hurtbox defaults could be used to reset hurtboxes when we return to certain states. And so no matter where this hurtbox is, the proper details will be set in this hurtbox defaults structure array. And we want to do this here as well. So we're going to make a new hurtbox detail structure array with the world scale and the relative location of the static mesh component, which again is our hurtbox, and then add it to this array here. So this is pretty simple. If we can make an f hurtbox detail structure, f default hurtbox details. And if we go to this structure, I know it's in our fighter template character.h, we can see what it is composed of. And it's just the scale and the offset. So the two things that we were adding to it in the blueprint. So in here we can simply add the static mesh child component get relative scale 3D and static mesh child component get relative location. Add the hurtbox to the array. Add the default data about the hurtbox to the array. Now to actually add this to the array, it is called our hurtbox defaults array. So hurtbox defaults.add. Then you can add this in here. And this line is pretty long, so if you want you could enter it down like that to keep it cleaned up here. This is pretty much ready. There's one thing that we're not doing in here that we'll need to do, but we'll get back to that later. And the other thing we need to do is this part. So once the loop is completed in code, we can just go below the for loop. We need to check to see if it should be set to visible or hidden by default. And we can do this by going back to the code, go below our for loop, and get our game instance. If u base game instance pointer base game instance equals cast u base game instance, and we're casting get game instance. So get the current game instance, cast it to our game instance. If that succeeds, we know we can grab variables from it because it's valid since we put it in this if statement. So when we come in here, we can perform a switch statement, switch parentheses base game instance, and this needs to be base game instance game mode type. So we're going to perform this switch statement on this enum value, just like we're doing here. Then we can fill out our cases for this. So case e game mode type colon, and we can pick whatever type we want here to start. I'm going to do it in the order of the enum itself. So it's actually versus, practice, story, arcade, online. I'm going to put practice at the bottom. I'll show you why. So we can do it e_versus colon. Then we can just add another case here, case e game mode type story, case e game mode type colon arcade, and case e game mode type colon e_online. Then we'll put break at the end of this. And in that section, between the online and the break, we will then set the hurtbox visibility to be visible. I'm going to enter all this in. So essentially what we're doing here is if it's any of these cases, I'm not breaking. And the way a switch statement works is it starts at the first one and it goes line by line until it hits a break. And once it hits a break, it will break out of the switch statement. So if it hits this first one, it's going to go to the next line, next line, next line, and then do this logic. If it's story, it's going to go next line, and then do this logic. If it's arcade, it's going to go next line, do this logic, and if it's online, it's going to go next line and do this logic here. So all of these are going to do the same thing, and you'll notice that's what's happening in this switch statement here. The only time it's different is in practice mode. So what I'm doing at this point is looping through the simple hurtbox array and setting them to be invisible if this is the case, if it's any of these game mode types. So you could set these when looping through initially, but this is fine to keep the same for now because you may want to do other things in here after your entire array is constructed, so I could see the use case for it. What we are going to do though is have a for loop in here, u static mesh component, pointer, simple hurtbox, simple hurtbox array. Then for each of these, we're going to say simple hurtbox set visibility, and we're going to just set the appropriate value. So if it's any of these ones, if it's not practice, we're setting it to be hidden. So set visibility false. Then at the end, we're going to break. And you can add curly braces to your case if you want. You don't have to. But if that looks nicer for you, you can. And then after this case, we can have another case. And this one's going to be e game mode type e_practice. And we do want to break in here. But instead, we're going to copy this for loop and set visibility to be true. they are on by default in practice mode. And again, if you want, you can put curly braces around your case. Set the visibility of the hurt boxes based on the e-game mode type. There we go, and that is that function completely converted. I do want to change the name now that we've gone through the logic. I think this should be called setup simple hurtboxes with an ES, so I am going to change that in the header file as well. Setup simple hurtboxes, and same with setup complex hurtboxes. So I will rename this other function too. And we're good to go. Then we just have to port this logic over to set up complex hurtboxes and make the necessary changes. So before we copy everything over from simple hurtboxes to complex hurtboxes, let's try building. And when we do this, we will get an error. This error is because we can't actually construct an fdefault hurtbox detail structure by passing the values into it. We need to set up a constructor if we want to do that. So if we come into our fighter template character.h and go to our struct fdefault hurtbox details and we make a constructor, we can make a default constructor. So fdefault hurtbox details parentheses. And then we can make an overloaded constructor, which is where we pass it parameters and set values in the structure to those passed in parameters. We can do it with an initializer list, just like we do our regular class constructors. So fdefault hurtbox details, parentheses, colon, scale, and then in parentheses we'll use our variable that we're going to pass into it, which will be underscore scale, comma, offset, and then pass in underscore offset. Then in the parentheses for the constructor itself, we're going to make f-vector underscore scale and f-vector underscore offset. That's what's being passed into this constructor and then being used to set the scale and the offset. Make sure you put your curly braces for your default constructor as well to have default implementation. It just doesn't do anything, but that's fine for now. Try building again after that and you will succeed. Then once you do that, you can go back into the editor and we need to see what's different between the simple hurtbox details and the complex hurtbox details. So you'll see that in the complex hurtbox details, we are looping through all the children components of the mesh. We're checking to see if it's a static mesh component. If it is, we are getting the name of it and comparing it to collision HB or collision hurtbox. So this is different than the simple hurtbox one because we were comparing it to HB underscore or hurtbox underscore. So the name is different. And then we're also adding it to the complex hurtbox array instead of the simple hurtbox array. Once we know what we're doing, we can go ahead and copy the logic from setup simple hurtboxes into setup complex hurtboxes. However, I don't think this is really the best way to do it. This logic is very similar. If we want to support both in the series, we could easily combine this into one function. But for the time being, let's go ahead and copy this over. Assuming we were going to do it this way, one of the things we would need to change is our string comparison, which I mentioned. However, you'll notice that if you go into your mutant BP or a character that has complex hurtboxes, the collision HB or the collision hurtbox tag on the name there is something I put at the end of it. So the string is the type of hurtbox like left or head and then collision HB. So when we are checking for this, instead of checking for if the static mesh child component get name dot starts with HB, we need to see if it dot ends with collision HB. And that will check for our complex hurtboxes. Then we can change our array over from simple hurtbox array to complex hurtbox array. We also were not using the hurtbox default system in the complex hurtboxes. You definitely could if you want, but since they're attached to the mesh, they move as the character moves and we do not need to manually reposition them. I'm just going to take that part out. Then we do want the hurtbox visibility behavior in here as well, but I'm going to change the names from simple hurtbox to complex hurtbox, and I'm going to change the array we're looping through from simple hurtbox array to complex hurtbox array. Make sure you do this for both the set visibility to false and set visibility to true. Now once we've done this, we can assume that we can make this by combining this into one function. And we have a few different methods we could do this as well. So first method is to make the function name something like setup hurtboxes, and not specify if it's simple or complex, but then add a boolean like is using complex hurtboxes. This will allow us to completely accept or remove a certain type. Like if we only want to have this match as a 2D match, we can say is using complex hurtboxes is false, and then we will ignore all complex hurtboxes. I'm going to change the name regardless to setup hurtboxes, and I'm going to change the comment as well to make sense for both of these situations. At that point, I can actually remove setup complex hurtboxes, and I could add my boolean here if I want. My bool is using complex hurtboxes. Again, this is optional. I'm actually going to show you how to do it without using this boolean, but keep that in mind. If you want to have that as an option to ignore a certain type, you could do it with that boolean. I'm going to remove the setup complex hurtboxes function, and I'm going to show you how we can combine these. So below the if statement where we're checking for if the name starts with HB underscore, I'm going to add an else if statement and see if the static mesh child component getName.ends with collision HB, just like we did in the previous example. If it does, then we can basically just copy the logic from the if statement above, but I am going to separate them with a comment now that we are putting them in the same function. So add the simple hurtbox to the array, and in this section we're going to add the complex hurtbox to the array. We do need to change the array type to be the corresponding one, as I do want to keep them separate for the purposes of the series. And now the logic has been properly converted so that both of them are supported in the same function. I'm going to remove that boolean that I was mentioning earlier as I'm not using it, but again, feel free to use it if you want to. And then below here where we're setting the visibility of the hurtboxes, we have a few ways we can tackle this as well. So the first option is we could just copy this section and paste it in the area for both. So if we're in simple hurtboxes, then this logic will already work, but we don't need to do a for loop here. So now we can just take away the for loop and set the visibility of the static mesh child component directly. This variable that we were adding to our array, we can just use that and set the visibility to false. So now every time a hurtbox is assigned and set up, it will have its visibility set here. Make sure to take it out of the practice mode case as well and change the variable. And this will work. But the problem with this is if we do it this way, we have to copy it into the complex hurtbox section, the else if as well. And while that works, that's duplicate logic that we don't really need to have, because if you look at them, they're doing the same thing at this point. There is a way we could simplify this, however. You'll notice that both of these sections are under the if statement where we create the static mesh child component variable, and that is now what we're setting the visibility on. So that means we no longer need to have this section on setting the visibility in either of these if statements. Not the if, not the else if. We can put it just outside of it, just as long as we put it within the if statement where the static mesh child component was created, and we have. The problem with this, however, if it is a static mesh component but it's not a hurtbox, we're still going to be setting the visibility on it, and that's not what we want. We want this function to be only for the hurtboxes. However, we can fix this as well by adding an else statement to catch those other static mesh components that aren't simple hurtboxes and not complex hurtboxes, and we can just choose to do nothing there. Stop dealing with the current element of the for loop that we're dealing with. So typically I would do a break in here, but a break will get you out of the for loop. In this case, we just want to skip the element. So we'll really want to do a continue. And putting a comment here, this static mesh component is not a hurtbox, so ignore it. So if we make this a continue and we get to this point, we're just going to skip the current element and go to the next one in the for loop, which very may well be a hurtbox of some type. So then we would still set the visibility on that hurtbox. Now there's one more thing I want to do, and that is actually add 2 booleans to this function. I know earlier I said I didn't want to add booleans to exclude any of them, whether it be our simple or complex hurtbox types, but I was thinking about it more and I realized that we should actually give full control so that you can do whatever you want with it. So if we add 2 booleans, bool is using simple hurtboxes and bool is using complex hurtboxes, this allows us to toggle one of them on, both of them on, or neither of them on. And that will allow us to do a lot of things in the future if we need to. Once we add these, if we also just check for the corresponding boolean in the if statement where we're checking to see if the name matches the HB underscore or the collision HB, so simple or complex hurtboxes, then we will only add the corresponding hurtboxes when this function is called. Again, we'll have full control over what we're spawning. Once that's done, we can go into our editor and go to the character blueprint and search for anywhere that set simple hurtbox details is being used. You'll see it's only being used in one place, spawn hurtboxes. So we can just replace that node and that function call with our new function, set up hurtboxes. Make sure we check is using simple hurtboxes so that it is true. At that point, we can delete the set simple hurtbox details function from the character blueprint. Now we can also replace the set complex hurtbox details function with the setup hurtboxes, checking the is using complex hurtboxes boolean. Once we do this, our logic will be working. However, to delete set complex hurtbox details, you'll see that we can't yet. So let's find references. It's nowhere in this file, so let's use the binoculars. You'll see it's in some of our character blueprints, our children of the base character BP. So if we go to the one here, which is the mutant BP, we had some logic where if we didn't want to attach the complex hurtboxes as a child of the mesh, we could still manually attach them, which I think is great. However, we don't actually need to do this for any reason, and I recommend we just delete this and then delete overridden function in the character blueprint. That way we can delete the parent function in the base character BP. Our one function in the code will now take care of all of that. Once you get that all cleaned up, test it out, make sure everything works, and you'll see that we can not only use our 2D and simple hurtboxes, crouch, resize them, reset them, everything is working beautifully, but we can also use our complex hurtboxes. So if we enable our 3D mode and see them here, you'll see they're attached to the character in the right spot, and they move with the character just as expected. Thank you guys so much for watching. I hope you enjoyed this episode. I hope it helped you improve your character in your fighting game. If it did and you enjoyed, please subscribe. It does more for myself and the channel than anything else you can do, and I really appreciate it. I want to give a huge shout out to all my YouTube membership, Patreon, and Discord subscribers. You guys are fantastic, and I'm so happy that you're loving the series. Thank you for all the love and support. I really appreciate it. If you ran into any problems following this tutorial or any of my tutorials, feel free to join the Discord community. There is a link in the description. I would be happy to help you out. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.